Let's talk about fertilizers as they are applied to the soil for plant growth. Fertilizers can be a controversial topic. A lot of people have a tendency to despise anything that's synthetic or inorganic, and a fertilizer is a chemical. It has some people may say that fertilizers produce unhealthy plants or poisonous plants, and it's important to understand the science of fertilizer and how it works. That's what we're going to discuss today. And I am a big proponent of organic methods and feeding plants naturally by having a healthy soil biology. But it's also important to understand how fertilizers work so that we can work with the soil and not do damage against the soil, understand which times certain methods may be more appropriate. And if we are going to either perform those methods ourselves or observe others doing those methods, we want to make sure we do it right and don't cause any problems or any damages. So we'll talk all about fertilizer today, and there will be a little bit of math, but I encourage you, do not fear the math. It will unlock the powerful tool of how to properly apply fertilizer. So here we go with our fertilizer talk. You can see here's the image of a person applying a granular fertilizer to a young plant. So, fertilizers are often thought of as plant food, but we know that plants make their own food through the process of photosynthesis. That's how they create sugar, going through photosynthesis, pulling in carbon dioxide and H2O. So, really, fertilizers are more accurately described as nutrients, or they're the minerals that our plants are needing from the soil. It's important to remember that. There's no calories typically in our fertilizer. Why do the soils lack nutrients? There can be many reasons. There may have been intense cropping on the land, like in an agricultural setting, and if you plant the field with density, you will deplete nutrients in the soil. And we need to add those nutrients back in one form or another. You may have poor organic matter in the soil, and that organic matter contains minerals, but also contains the organisms that unlock minerals and make them available to your plants. You may have an improper soil pH. As we have learned, if the soil is too acid or too alkaline, that can tie up nutrients. You may have poor aeration, so your soil could be lacking in oxygen due to compaction or overwatering, and that will inhibit nutrient uptake. And you may overwater your soil, which in sandy soils will allow nutrients to be washed through the root zone. And in general, you just may have low nutrient levels. Some types of soils, due to their origin, they simply never have enough of certain nutrients. Remember our nutrient classification, how we have the macronutrients and the micronutrients. We know that plants will need all of these minerals, but they need them in the proper concentrations. The primary thing they will need are the macronutrients, and the top three that they need to get from the soil are nitrogen, phosphorus, and potassium. So when we look at a typical fertilizer bag or any type of container that holds fertilizer, this could be organic or inorganic. There's a few things we need to be able to recognize in order to understand what's happening here. So there's basic information that you should always be looking out for, and it's the law that this information is printed on the package. So we want to make sure there's a product name, that the weight of the contents is there, and that the fertilizer has a grade. And the grade is made up of those three numbers, 10, 10, 10 in the example here. And you can see that that's related to nitrogen, phosphorus, and potassium. Now, some people out there call NPK fertilizer anything that is a fertilizer sold like this bag here, and they use the name NPK fertilizer to mean something synthetic or like a chemical that's going to kill the soil, kill the life in the soil, or potentially harm your plants or grow plants that will be poisonous for you. And that's not necessarily true. There may be some concerns with using synthetic or inorganic fertilizers in certain applications, but to just call it NPK fertilizer doesn't really tell you much. All fertilizers should have NPK, and NPK is just nitrogen, phosphorus, potassium. You can have organic sources of NPK, and compost has NPK in it. And so understanding the terminology, I think, helps us to shed any of our preconceived fears that we may have around something that we don't quite understand. But we always want to have safety in mind, which is why we learn the finer details of these things. So notice the grade here is 10, 10, 10. What that means is that the product, the bag itself, contains 10% nitrogen, 10% phosphate, and 10% potash. This is the NPK, and the number is simply a grade that tells you how concentrated this material is in each of those elements. And notice that the product also contains 50 pounds of fertilizer, and we need to know the overall weight in order to understand how to properly apply this bag of fertilizer. NPK are the top 3 nutrients that plants need, but we know they need many others, 17 at least. And so this bag may have other nutrients. Very likely it will have other nutrients. And the best way to find out what else is in this bag is to look on the back, and it should include a guaranteed analysis statement. And that will tell you exactly what's in the bag. Notice that the nitrogen, phosphorus, and potassium are not necessarily pure. They have to be in that ionic compound form. And in order to exist in an ionic compound, they have to be bonded together with other elements, oftentimes. And so we want to know what those elements are. So here's an example of a typical guaranteed analysis. This is for a 1668, which is a very standard turf fertilizer, something you'd put on the grass that's not too strong. So you can see the guaranteed analysis breaks down the percentage of nitrogen, phosphate, and potash. It also explains what formulas those are in. And then we have a sulfur analysis as well, and iron, 1.5% iron. And then you can see a whole host of compounds that create the iron in the fertilizer. And so we're not just putting down the 3 letters, we're putting down the combinations as well. What I just described to you is the grade of the fertilizer, those 3 numbers, NPK. And if you want to apply NPK to your soil, you can apply fertilizer in a wide variety of grades, more highly concentrated or less highly concentrated, or more heavily concentrated with nitrogen, or maybe one that's a higher concentration of phosphorus and a lower concentration of nitrogen. But Fertilizers also come in different forms, and we'll talk about those forms now. We typically refer to them as formulations, and the two general categories are liquid or granule. And within that, there's some modifications as well. So with granules, this is a dry fertilizer product that resembles sand, like a large grain of sand, little pebbles. And this is formulated as a granule so it can be easy to broadcast over an area. You would water these in after you apply the fertilizer. And the accuracy of your application depends on the applicator, not just the tool you use, but the person using the tool. They need to understand how to properly apply these granule fertilizers in order to not have high concentrations and missing any spots. There are different granule sizes, and you want uniform sizes when you apply granules, so that way you have accurate distribution. If the fertilizer is poor quality, you may have large and small granules, and when you broadcast them, they won't be spread evenly. And we use several different tools to apply granule fertilizers. The first tool that we would use is a handheld broadcast spreader. So this is a spreader. Oftentimes they're made of plastic, very inexpensive, but you want to find the best one you can because the higher quality, the more accurate it will be. You fill the hopper with granules and you rotate that handle. And as you do, it spins a wheel that throws the granules out in all directions. These handheld broadcast spreaders are good for small lawns or little shrub beds and ground cover areas where you just need to get in and apply a little bit of fertilizer. The accuracy is very dependent on the person using the spreader, so it can be difficult to know for sure how much you're spreading or how accurate you are. The next step up as far as accuracy as well as cost is a broadcast spreader that is typically based on a larger hopper and it's on wheels. This is a very fast way to apply fertilizer to large areas, and it can be very accurate if used properly because you can see the distance of throw and you can basically walk at a steady pace over the entire area. And if you walk faster, the wheel will spin faster. If you walk slower, the wheel will spin slower. So your speed is kind of moderated in that regard. Most of these throw fertilizer in a 6 to 8 foot swath. And you do want to overlap your pattern of distribution. If it spreads to the left side, 3 feet, you go down a row and you would turn around and you would have it now throw to the right side 3 feet. So you get kind of a double coverage. The goal is to have an overlapped coverage over an entire area, similar to how you would operate a lawnmower. These can be a little bit top heavy because they hold all of the material in that hopper. And so there is a tendency maybe for having this spill. Say you put 50 pounds in this spreader. If you're not cautious as you load it in, it could tip and spill, and we never want that to happen. There's also an on and off lever. So you want to always make sure you have the opening closed at the bottom before you apply the fertilizer. And there's an image there of what it looks like when you burn the grass by applying too much. We want to avoid that. That looks like it was probably a spill of some sort. The next step up in accuracy, but also in skill required, is a drop spreader. So instead of throwing this material out, this material simply drops out of the bottom of the spreader. This is very precise because the material simply just has to go a small distance and it's hit the soil surface. It's typically a little slower to apply than a broadcast spreader because you're covering less of an area with each pass. And this is nice because you can also use this to apply seeds. So if you want to add new seeds to your lawn, you can use the same tool to spread seed. In fact, you could potentially combine seed and fertilizer, but be careful in doing so. You want to make sure you select the proper uh, material that can handle that. And one thing to pay attention to with this, because it only is applied where it drops, you want to make sure that you don't miss any spots. It will become very obvious if you miss spots. And one of the places most people miss are the wheels themselves, the thickness of the wheel. If you go down a row and then turn around and come back the other way, you have to overlap for the distance of those wheels. And so the image there shows stripes in a lawn due to uneven fertilizer application. And then we have liquid formulations. These are nutrients that are dissolved in a liquid form. And you can have two types of liquid formulations. One would be concentrated, meaning you buy it and dilute it yourself later. And the next is not concentrated, it's called ready to use. Most of the people who are professionals will use concentrated because it's cheaper and you can buy less product and cover a larger area. When you buy ready to use formulations, all you're really doing is buying the nutrients plus a lot of water. It's been diluted and calibrated for you. So that's good for a homeowner. It's very convenient, but it is more expensive in the long run. So it's worth it to learn how to properly calibrate and dissolve a concentrated liquid formulation. Liquid formulations are good because they can be absorbed quickly into the root system. So this material does not need to linger in the soil for very long. It is taken up very quickly within a matter of hours into the plant's roots. In some cases, it may be sprayed on the foliage and small amounts will be absorbed into the leaves themselves, and that can be useful in certain circumstances. And these diluted liquids will eliminate burn problems. So you'll be much less likely to see physical burning in the turf or on shrubs because you're applying it in a diluted form. If you have a fertilization regime where you are fertilizing little bits, but very often, like every week over the course of a year, then a liquid formulation is much easier to apply. But the downside of the liquid is that it doesn't leave any nutrients behind. So there's nothing that's going to act as long-term feeding. So a liquid formulation, the pro is the con. It gets into the plant quick, but it doesn't really linger in the soil. And that may be a good thing or it may be a bad thing based on your specific circumstances. The most basic tool we use to apply liquid formulation is with a hose end sprayer. With this hose end sprayer, this is a entry level residential. You want to add the diluted fertilizer into the bottle. So as water goes from the hose to the nozzle, it pulls the diluted fertilizer up, and there's little need to calibrate or worry about the accuracy of this because it's already diluted. Now, when we look at a more commercial application, a more heavy duty and more accurate hose end sprayer, this one can handle non-diluted formulations. And so this sprayer allows you to pour the concentrated material into the jar. There's a little dial on top that will dilute it to the proper amount, and you can adjust that. The nice thing about this is that the material in the jar never touches the water, and so you can fill this up, and if you only use half of it, you can leave it like that for next time because you haven't added any water to the jar of concentrated fertilizer. There are other liquid formulations, and one of them is injection. So, in particular for trees, you can actually inject the liquid fertilizer directly into the trunk. And what this does is it goes straight into the xylem or the sapwood and is pulled up by the tree. This could be beneficial if you have a pH imbalance and the minerals are locked in your soil and are not soluble at a certain pH. You could potentially come along and just literally inject the nutrients directly into the tree. This would not be practical on a regular sort of maintenance fertilization, but if you are trying to take care of a sick tree that is suffering from oftentimes pests and diseases, if you come in and give it an injection of all the minerals it needs, oftentimes that helps the tree to perk up and fight off the pest itself. Although this requires some extra skill and equipment, it does not hurt the tree long term, and it is a very efficient method. There is zero material wasted. And so oftentimes this will be almost like what a tree doctor would do and come and put you on the IV, give you the direct injection of the medicine. There are also slow release pellets. These are often larger in size and they can be added to containers, pots, or to a planting hole. And these will break down more slowly over time. Sometimes they have special coatings like a polymer, a biopolymer that will decompose over time but requires the microorganisms to break them down before it releases the minerals. And so you would need to apply this less often, and you can feed for up to 6 months with a slow release. Usually, slow release is considered a good way to go. And then on farms and agricultural settings, we have fertigation. So it's like the name suggests, it's fertilizer added to irrigation water. And if you already have the method of distributing liquid to every plant in the form of an irrigation system, it's very efficient then to just put the concentrated fertilizer into the irrigation system itself. And now every pipe, every nozzle is going to be applying not just water to your plants, but fertilizer as well. You can use this with many kinds of irrigation systems, including drip irrigation. And you can also use this with either organic based or synthetic based liquid fertilizers. Fertigation is a great way to go. So let's take a moment to talk about synthetic versus organic versus inorganic. A lot of people have opinions about these terms, and they don't necessarily use the terms properly. And they also may have judgments about them that are not fair because they're misinformed. And so there are different ways to think about all of these things. I'm going to present them in a way that I think is helpful from a fertilizer perspective and from a soil health perspective. These terms are a classification when it comes to fertilizer, and it's based on either the method of production or of the origin. It really doesn't necessarily refer to the safety. A lot of people think, oh, organic, that's like my organic food, my certified organic food. It hasn't been sprayed with chemicals, so it must be safe to eat. When we're talking about fertilizers, we're not necessarily talking about that type of organic. So our first category we'll discuss is synthetic inorganic. So synthetic is anything that is manufactured in a factory, and inorganic typically refers to minerals that are extracted from the ground. So a lot of people would say synthetic means it's toxic chemicals. That's not necessarily true, but what synthetic is chemicals that are very precise. We know exactly what they are. They are not naturally occurring. We need to take in natural things and in a laboratory or factory setting, do perform various chemical reactions, and we will then get a byproduct that is the synthetic and oftentimes synthetic inorganic compound. And then we have organic fertilizers. These are fertilizers that came from something that was once alive. So here the term organic means living. And in this case, mainly we're talking about animal and plant residues and manures. So you can think, okay, well, there's a compost pile and you go to a farm, there's a pile of horse manure. That is an organic fertilizer, but that would be more like an amendment to the soil. When you buy organic fertilizers, they are still given a guaranteed analysis and a grade. They just came from a living source as opposed to a synthetic source. And then finally, we have synthetic organic. This is something that was manufactured in a factory, but it has carbon in it. And so it was once alive at one point, but may not have come, very recently from an animal or a plant. So one example of the synthetic organic is urea. Urea is often added to an inorganic synthetic fertilizer to add high levels of nitrogen. Now, none of these tell you anything about the concentration. The concentration is really where you have issues with safety. Too high of a concentration of any of these materials will equal pollution, and it can be toxic to you or to your plants. The other thing that a lot of people don't consider is that there is one advantage of synthetic over organic, and synthetic has a guarantee. It should not have other chemical compounds other than the ones they are creating with the laboratory reactions. Organic compounds, however, derived from living things, will have some natural variation. A good example is any kind of compound that comes from a whole group of plants related to apples and cherries. They contain cyanide compounds in their seeds. And if you have high concentrations of cyanide, that is a deadly toxin to humans. And some organic derived products will have varying amounts of these secondary materials that are not necessarily guaranteed because different individuals from that species will have higher or lower amounts, and the environment will alter or vary the amounts of active chemicals. So there is some potential to have uh, side effects with organic that you would not have with synthetic. But for the most part, people are inclined to choose organic, and rightly so, because it tends to be less concentrated. The synthetic chemicals, they can get much more concentration than you would naturally find, in nature from a derived source. And so therefore there is that potential with most synthetic fertilizers to have a higher chance of causing harm. The other thing that is a benefit for organic fertilizers is that oftentimes there's less embodied energy. Many times you can go and just scoop up the material off the ground if it's horse manure or guano from birds, or if it is a compost pile, for instance, humic acid from a worm bin. It doesn't take a lot of energy to produce that, and perhaps it is rapidly renewable. So, as a resource, it's not as likely to run out. Whereas if we go with inorganic and synthetic fertilizers, those do tend to require more energy. There's more electricity that it took to make the product, transportation, and all sorts of embodied energy that, from an environmental perspective, may not be as conducive to the kinds of things you want to have happening in and around your garden. And so there's kind of the ethical choice between synthetic versus organic. There's also the environmental choice. And if you are growing organic food and you want to sell it as an organic product, well, then you certainly need to choose organic fertilizers. There are some times, however, especially like on a sports field or with golf courses, for instance, that synthetic is just much more accurate. There's less waste, there's less potential damage that you can cause, and that would be probably the way to go. So the thing here is that there's no one right answer. There's no room here to have dogmatic opinions. It's more about finding the appropriate path for your specific circumstance. Here's some examples of these various fertilizer classifications. So you can see the inorganic synthetic. We often have things like ammonium nitrate, ammonium sulfate. Remember, those are things that occur in the soil as a byproduct of living things, but not necessarily something that you can pick up in the soil or have in any concentration. And so all of those different things that end in nitrate, sulfate, phosphate, that tells us it's an ionic compound that is water soluble, will be rapidly taken in by your plants. Now, when we have organic fertilizers, these are things like blood meal, bone meal, fish emulsion, cottonseed meal, manure, and guano, which comes from birds, and a lot of times comes from bats as well. So that doesn't necessarily mean these are healthier for you. You can get sick if you have a improper handling or application of the organics, but it just tells you these are derived from things that were once alive, and they still have the same guaranteed analysis. They still have the same grading system as a fertilizer, and you should treat them like any type of fertilizer so that you make sure you follow proper protocols. And then for the synthetic organic, we have urea formaldehyde UF, and that one is typically very highly concentrated. So I mentioned it's all about the concentration, and so we need to understand how to apply fertilizer in various rates. It is a simple process, but it is frequently done improperly. A lot of people just say, if a little bit's good, a lot should be better. That's not necessarily the case. We want to make sure we apply exactly the right amount. And why is it important to apply the right amount? Well, if we don't, we can either not give our plants enough nutrients or too much. If we give them too much, we can kill them. We can burn the plants, especially if we're using synthetic inorganics in the form of these ionic compounds or these salts. It will burn the plant. We can potentially apply nutrients in areas where the plants can't absorb them. We can have nutrients be lost to the atmosphere or washed into the stormwater system, gutters, streams, and lakes. We don't want either of those to happen. That's pollution. And if even on the small scale, you can get fertilizer, nutrients applied to the walkways and the patios, and that will stain sidewalk. It'll be unsightly, and it's just not a good practice. It also wastes money and is disrespect for the resource. So there's a few rules of thumb that you'll pick up over time as you apply fertilizer. The standard rule of thumb when we look at grass in particular is that turf grass prefers to be fed during the growing season. So we have cool season and warm season grasses. So you only give the fertilizer when it's growing. And in general, we want to apply 1 pound of actual nitrogen per 1,000 square feet per month that it's growing. So there's some things you got to figure out here, isn't there? Some fertilizer bags will tell you how much to apply per 1,000 square feet, but some do not have any application rates listed, and they think that you're smart enough to figure it out. A lot of times, the commercial fertilizers will just simply give you the fertilizer with the grade and the net weight. You need to use that information to figure out how to properly apply your fertilizer. So let's do some examples. The first thing you need to do is examine the fertilizer's grade. So let's say we have 1668, which would be 16% nitrogen This is our standard turf supreme. What we want to do is convert the percent into a decimal. We want to express it in decimal form. And so we know that 16% is 0.16. There are a couple of ways to get to the answer, but I find the simplest is to just focus on this shortcut. If you remember high school math and how to cross multiply, then you'll be much more brushed up on how to figure it out the standard way. But if that kind of hurts your head, just worry about following this simple formula. We're going to need to divide the percent of nitrogen into the amount needed. So what does that look like? We need 1 pound of actual nitrogen per 1,000 square feet per growing month. So we take 1 divided by 0.16. We divide 16% into the amount we need, which is 1 pound. And that is a shortcut, which will then tell us that what we need is 6.25 pounds. 6.25 pounds for what? For every 1,000 square feet every month. You can figure out how many times in a 50-pound bag you'll be able to apply that, and you'll use a little scale. You'll weigh out 6.25 pounds of material, and then you'll put it in your spreader, and you'll apply it each month over the given area. But what if your lawn is not exactly 1,000 square feet? That's rarely the case. Let's say you have 7,550 square feet of area that you're fertilizing, and it's in this case a field or a lawn. We're going to convert that number, the actual area in square feet, to how many thousands of square feet you have. Because we know how to get to 1,000 square feet. Well, how many times do we need to do that? So 7,550 becomes 7.550. That's how many 1,000s we have in 7,550. So we take our 6.25, which is how much we need to apply for every 1,000 feet. We multiply that by 7.55, and we get 47.2. So that's the amount we'll need to apply every month over the entire area, 7,550 square feet. Let's say I need to fertilize a golf course turf area. I decide to use a 25/8 in April because I want to apply a complete feed to my turf. Later in June, I will apply a 33/00 just to green up the turf with the nitrogen content. But both bags have no instructions for the application. What do I do? So remember, we need 1 pound of actual nitrogen per 1,000 square feet of area. That's 1 pound of nitrogen, not 1 pound of fertilizer. Don't get it mistaken. 1 pound of nitrogen. So in my first bag of 25/8, that is 20% nitrogen. Or for every 1 pound of fertilizer, it's 0.2 pounds of nitrogen. So once again, we simply divide 1 pound of nitrogen because that's how much we need. We divide that by 0.2, and that gives you 5 pounds of fertilizer. This means that I need to apply 5 pounds of fertilizer to every 1,000 square feet of turf to apply 1 pound of actual nitrogen to 1,000 square feet of turf. So we can calibrate our spreader to apply 5 pounds of fertilizer for 1,000 square feet of turf. And when we do that, the grass will be properly fed. But what about when we want to use the 33/00 in June? We're going to need to recalculate and recalibrate. Here we will divide 1 pound of fertilizer by 0.33. That's the percent of nitrogen. And then we get 3 pounds of fertilizer for every 1,000 square feet of turf. But how about citrus trees? That's not a grass area, and it's a little more difficult to consider the overall root zone and calculate the square footage. What do we do with a tree or a shrub? Typically, trees are fed based on the size of their trunk diameter or by the diameter of the drip line of the tree. Now, the drip line is everywhere that the branches above the ground extend. So if your branch goes out 5 feet in all directions, you have a 10-foot diameter drip line of the tree. Think about it. If it was raining, where is it going to drip off of the tree? And we call that area the drip line. So to properly feed a tree, we need to know the total area covered by the root system. If we assume our citrus tree is 20 feet across in diameter, that means the roots would extend outward 10 feet from the trunk. We're assuming that what's happening above ground is similar to what's happening below ground. That is not 100% accurate, but it works enough as an assumption to properly fertilize this tree. So we'll take you back to 10th grade geometry. The formula for the area of a circle is pi times radius squared, 3.14 times r squared. Maybe it takes you back to 7th grade geometry. So in this case, the radius, which is half of the diameter, the branch goes out from the trunk to the edge, 10 feet. That's the radius of this circle. May not be a perfect circle, but it works enough. We do 3.14 times the radius, which is 10 feet. But it's the radius squared, so it's 10 times 10. 3.14 times 10 times 10. That gives you the amount of square footage under your tree, 314 square feet. Citrus trees require about 2 pounds of actual nitrogen per 1,000 square feet of area. And a common fertilizer for trees and shrubs is 10, 10, 10. And so since we want to apply 2 pounds of actual nitrogen per 1,000 square feet, we need to divide 2 by 0.1, which is our percent nitrogen. And then we get 20 pounds of fertilizer applied to every 1,000 square feet of area. Now remember our tree, we decided has 314 square feet of root area. So in order to compare this to the 1,000 square feet, we need to divide 314 by 1,000. That gives us 0.314. So we have 20 pounds of nitrogen times 0.314. That gives you 6.28 pounds. Sometimes when you're not sure whether you should multiply or divide, I recommend try to think about it logically. We know we need 20 pounds in 1,000 square feet. 314 square feet is about 1/3 of 1,000 square feet. So we're going to need about 1/3 of 20 pounds, which is 6.28. And so when in doubt, just double check your math by asking yourself logically, does this make sense? If you multiplied by 1,000 and you'd have 314,000 square feet times 20, you'll end up with a crazy huge number. That doesn't make sense. So always check your math with simple logic. And we take our 6.28 pounds, we want to spread it evenly on the soil over the root zone, scratch it in, and then water thoroughly. So there we go. There's a little introduction to fertilizers, their contents, their formulations, and how to think about properly applying fertilizers in the right amount. I hope you gained something from this talk, and that next time when you observe someone applying fertilizer, or when you yourself attempt to apply fertilizer to a landscape area, you will have more knowledge, you will lead to less waste, you'll be much more safe, and you will have a healthier garden.